Welcome to lab number 6, part 3 of 3. On the first part, I went over an overview explaining all the different components involved in building a VxLAN EVPN BGP fabric with asymmetric IRB. On the second video, I went over some of the terms that are part of this VxLAN protocol, so that way we have a better understanding about all the different components. And on this particular video, the purpose of this video is to show you how the running configuration looks like in leaf 1, how the running configuration look in spine 1, and then you're going to have an idea how it's going to look in spine 2 and on leaf 2. So that is the purpose of this video. Show running config, show running configuration compressed, and let's take a look at some of the entries that we have on this running configuration leaf 1. So if you look here on the right, this is the leaf that I am going to be referring to initially. So the first thing I see here, I see that there is a couple of VRF instances. One of the first VRF is a default VRF. The second one is tenant 1. So what it's telling me, let's go here on the bottom right. What I'm going to draw here is a physical switch. So this switch over here is a multi-layer switch that can do layer 2, layer 3. And the idea here is that by using the virtual routing and forwarding feature, what it's saying here is that we have at least 2 partitions, right? So one partition is going to divide the switch for this VxLAN EVPN BGP fabric process. So let's call this VRF tenant 1, virtual routing and forwarding tenant 1, and tenant 1 has its own routing table, which is going to be here. It's going to be basically the routing function for the underlay, and also for the BTAP, that is the routing function for the overlay. And then it's saying that there is another VRF, another partition on that switch with ports associated to this other VRF called default. VRF default. And on this VRF default, it has its own routing table isolated from the one on VRF tenant 1. It's going to have its own associated ports to this VRF default. Another thing that is recommended is to create another VRF, virtual routing and forwarding, for the management interface. So that way you can put the out-of-band management interface, which is a interface management 111, and place it on this VRF management that is going to have its own routing table isolated from the other 2 instances of VRFs. Okay, so for the most part, this running configuration is going to focus on this VRF tenant 1 because that's the one that is of interest for us, right? Which is part of this fabric that I am creating. All right, so having said that, let's continue. There is a virtual router MAC address, which is going to be 00, 01, 01, 01, 01, 01, for example. The host name is already, leaf 1. And that's what is representing on this leaf that I am connecting to. There is some iSCSI information, but I'm not configuring any SCSI at this point. If I keep on scrolling down, another thing that catch my eye is that it's telling us on this running configuration that there is two virtual networks, Virtual Network 1002 and Virtual Network 1004. So let's go ahead and point those two on this topology. Is referring to this one right here, VNI 1002 and VNI 1004, and it's basically telling me that there is a couple of networking virtualization overlays. In this case, it's going to be VNI 1004, which is this red line, and VNI 1002, which is the purple line. And that's it. It's just saying that. So let's continue. I'm going to skip the port groups. It's interface VLAN 1. So let's get rid of this highlighting. So interface VLAN 1. So let's go ahead and write it down here. Interface VLAN 1. No shutdown. The next thing that I see here is that there is a loopback 0 configured with the IP address of 10.1.1/32, and that loopback address, so it's gonna be, so let's put here loopback 0, and the IP address is 10.1.1/32, and this loopback IP address is going to be used by the VTAP as the source IP address to identify it on this EVPN BGP process, and VTAP2 is going to inherit that loopback address that is going to be configured on leaf 2, which is going to be 10.1.1.2/32, and this loopback address is going to be the source IP address for VTAP2, and that's how it's going to be identified on this EVPN BGP process. And while we're here, let's go ahead and draw another switch here, right? And only the leaves are the ones that have this VTAP feature turned on. As you can see, VTAP1 and VTAP2. Another thing to say here is that it's part of the autonomous system number 65021. Okay, so having said that, let's move on. Okay, the next thing I see on this configuration is going to be that it mentions that it has the networking virtualization endpoint activated, which is going to be, let me highlight it here on the right, which is actually the VTAP, the virtual the VxLAN tunneling endpoint 1 and virtual VxLAN tunneling endpoint 2. So let's make a note here. So this VTAP is also known as the network virtualization endpoint. Okay, so, and then it's telling me that the source interface, the IP address for this NVE or VTAP 1 or VTAP 2 is going to be the loopback address. That's what I mentioned a few seconds ago. So let's remove this highlighting and these notes, so that way this drawing is not too busy, okay, or over cluttered. So let's continue. The interface management is configured to obtain an IP address by using a DHCP server, which is fine. Then for interface Ethernet 111, it's just telling us that it's going to be the link to the end host 1. So let's go ahead and identify that particular interface, which is this one over here, Ethernet 111. And then it's saying that this port is going to be in trunk mode. So let's make a note here, trunk. And then on this particular set of entries, it's telling me that it's going to allow VLAN 1 to be allowed. So let's do VLAN 1. Okay. And then flow control receive is off. Okay, so that's that part. So now let's take a look at interface Ethernet 112, which is going to be a link to spine 1. So let's go ahead and highlight that. Let me see if I can use a different color here. Let's use orange. Okay, so it says link to spine 1. And so it's going to be this one right here. This link right here. Another thing to mention is that the IP address for that interface facing spine 1 is 172.16.32, which is this one right here. And another thing that is worth mentioning is that the maximum transfer unit is set to 1650. So this is important, so let me highlight it. So the MTU, if you are using storage, iSCSI storage for example, normally you want to have these MTUs to be jumbo frames. I think it's in the 9,000 bytes range. So you basically change the setting to jumbo frames if you're going to be using the storage. Now, a regular MTU is about 1532, but the VxLAN process will add extra bytes to the length. So that's why we need to increase the size of the maximum transfer unit to 1650. Some other protocols will tell you to do at least 1700 bytes as the minimum MTU. So that's another thing that caught my eye here. So let's look at interface Ethernet 113. And that's going to be a link to spine 2. And if you see over here on the left, the MTU size is 1650, like I said before. If you're going to be using storage, crank it up to jumbo frames. Let's see what else. And then the IP address to get to spine 2 is going to be this one over here, 172.16.7.130. So checked. And this basically is going to be this link right here. So now that I have configured that interface, let's keep on scrolling down. Then I see interface 114, which is the description link to endhost 2, and it's going to be the same as the route to endhost 1, in which we're going to do over here in 114. Well, let's use yellow. We're going to make sure that this port is in trunk mode, and we're going to allow VLAN 1 as well, and that will take care of 114. Let's see what else. Then it's telling us to go ahead and place the rest of the interfaces in VLAN 1, which I don't care because we're not dealing with those interfaces. So let's keep on going. All right, so now let's see. Let me go ahead and get rid of these highlights, so that way. Okay, so let's continue. Yeah, I just didn't know how to approach this lab because for me it makes sense, but I just want to make sure that whoever is watching this video follow the logic. and understand, what I'm trying to demonstrate on this lab. And keep in mind, I'm not teaching this lab, I'm just showing you as I work the lab myself. And if you have a chance to work on it, yeah, that is the idea, just to tell you, hey, this exists, OS 10 is real, a lot of customers are using it, and all different type of how to say this, mission critical applications. And so it's a very solid operating system from DELL. Okay, having said that, let's continue. The next entry I see on the running configuration for Leaf 1 is the configuration of the virtual network 1002. So what it's saying here is that this virtual network 1002, so let's use Orange again. So let's say that this VNI 1002 is part of the BRF forwarding tenant 1, which is this partition I mentioned. So let's go ahead and show this partition. So this is our BRF. That didn't work. Let's go back here. So this is our BRF tenant 1. And it says here that the IP address for this virtual network 1002 is going to be 192.168.102.2/24, and that the virtual router address is going to be 192.168.102.1. So that will take care of that overlay network 1002. Now for interface for the virtual interface, the virtual network 1004, which is also part of the forwarding tenant 1 BRF forwarding, which is part of the IP for BRF forwarding tenant 1. The IP address for that other VLAN or the subnet for the subnet for interface virtual network 1004, IP address 192.168.104.2/24, and the IP virtual router address is 192.168.104.1. So that will take care of this other virtual network. So let me just highlight it over here. So that's the red line. Let's continue down the path. So the next concept, the next entry on this running configuration is the Router Bgp process 65021, which is going to enable this ASN 65021 for Leaf 1, and it's the same process for Leaf 2. And then all we're doing here is that we're saying, let's use best path AS path multipath relax. So what it's saying here is that on this BGP domain, on this BGP EVPN fabric, to relax the rules and allow ASN 65021 and ASN 65022, which are two different autonomous system numbers, to play together. So that's what it's saying. It's just relaxing the rules. Then on this Router Bgp 65021, we are specifying that the address family IP before unicast is going to be used, that we have redistribute connected, meaning that any connected route to this leaf is going to be also redistributed on the EVPN BGP fabric. Then the next thing on Leaf 1 is to set the neighbor relationship, which in this case it will point to 172 16.3.1. So I'm gonna use a yellow highlighter just to make sure that I identify it here on the topology diagram, which is gonna be this one. This is gonna be the neighbor, okay, for that leaf1 BGP process. And then he's saying that the remote autonomous system is 65022, which is right, it's right there. And then no shutdown. If we continue down the line, yeah, we're gonna enable the address family IPv4 unicast, allow AS in 1, and then we're gonna specify the second neighbor, which in this case is gonna be 172.16.7.2. So let's look it up on the topology diagram, which is this one right here. So that's gonna be the second neighbor. And then, yeah, we're gonna specify address family IPv4 unicast, allow AS in 1. So let's continue. Okay, so that's for the underlay. Now for the overlay, and I might be wrong on this one. I'm gonna have to double check, but this is my understanding so far, that we are using the 10.1.1.3 and 10.1.1.4 for the overlay, and we are using also BGP. So that is my understanding. So this yellow, my understanding is for the underlay neighbor relationship for leaf1. So let me use a different color, and let's do another set of neighbor relationships, but this time let me use a smaller one. Yeah, this time is going to be for this neighbor, which is going to be the loopback address for that BTAP, if you remember. So just remember that this switch right here, let me use let's draw the switch, right, the multifunction switch here, and let's draw another multifunction switch for spine 2. And so what they're saying here is that the loopback address on this spine 1 is going to be 10.1.1.3/32, and the loopback address for spine 2 is going to be 10.1.1.4/32, and this IP address is going to be also, well, in this case there is no BTAP, so yeah, this loopback address is going to identify this router, this routing function on this multi-layer switch. Okay, so that makes sense. So now the neighbor is going to be this loopback address for the overlay. That is my understanding. The remote autonomous system is 65022, which is this one here on the center. So this ASN 65022 is going to be common for the spines, spine 1 and spine 2. Then it says send community extended. I think if I remember correctly, by establishing this neighbor relationship, that's going to permit a spine 1 and a spine 2 to inject routes into this BTAP router function, and that way BTAP 1 knows where to go when nhost 1 need to reach nhost 4. So that way nhost 1 will send, the request, hey, I need to reach nhost 4. Then the BTAP is going to have routing information, and then it's going to say, oh, okay, I got my update from the EVPN process, and that IP address that you want to go to is behind BTAP 2. And then you need to go exit this port, go to spine 2, drop, and then you are at your destination BTAP, and then exit via Ethernet 114. So that is the logic to allow to inject routes, if I'm not mistaken. I'll double check and I'll practice, and I'm gonna keep on practicing until I master this. Then it says update source loopback 0. That makes sense. We are using that loopback 0, 10, 1, 1, 3. So that makes sense. The address family IPv4 unicast, yep, to allow IPv4 addresses as part of the, you know, the allowed IP addresses into the EVPN process. Then, because we're gonna be injecting routes, whenever you are sending information on the overlay, the way that things communicate on the overlay is by using these layer 2 VPN, EVPN messages. So that's what we're doing here. We're saying, you know what, let's activate this type of L2 VPN messages that will allow us to update the routing information, the BTAPs, basically what's happening on the control plane. So I'm gonna draw it with green. So remember that with EVPN, the idea is to create a software-based control plane. That is the idea. Okay, so let's continue here. So that address family L2 VPN, EVPN messages are gonna be enabled because we are activating that function. Then the next relationship is gonna be to neighbor the next relationship is gonna be to neighbor 10.1.1.4, which is gonna be in spine 2, and we're gonna go ahead and send community extended as well to be able to inject routes into leaf 1, for example. And then we're gonna do the update source loopback 0, which is 10.1.1.4 on that neighbor. Let's see what else. Then we have the same address family IPv4 unicast for that particular neighbor, also to be able to use IPv4 unicast addresses. And then we're gonna enable address family L2 VPN, EVPN to send those messages on the overlay networks. And we're gonna go ahead and activate for neighbor 10.1.1.4, which is spine 2. If I scroll down, there is an EVPN entry that is saying that, hey, turn on EVPN, which is going to be this green box that I drew over here. So this is going to be our software-based control plane, right? And this software-based control plane is going to have the database, right, that is going to be built with those L2 VPN, EVPN messages. And let's draw it here with this color. So let's say that on this control plane, you're going to have, for example, any connector routes. You're going to have VTAP 1 and all the routes associated with VTAP 1. Then you're going to have information for VTAP 2 and all the routes connected to VTAP 2. And that's how you can make routing decisions on the overlay by enabling this software-based control plane. So if I keep on going down here, what we're doing is that it's saying that the virtual network 1002 is going to have member interface Ethernet 111, and it's gonna tag that VLAN 102 to virtual network 1002, and that is something I was mentioning on previous videos. So let me get rid of some of these highlight marks. Let's clean it up a little bit. So what they're saying here, let me just clean this up. Let me see if I can use a different color here. Let's use this one. Okay, so let's use that one. So what they're saying here is that we are tagging VLAN 102, which is going to be the VLAN here that is on this server. But this server basically is actually on the GNS3. We're using a DELL switch to mimic a server, and the idea is that this to be emulate perhaps an ESXi server that has multiple VMs, and it has its own virtual networking, and that we have established VLAN 102, right? And then what we're doing now is that we are associating VLAN 102 to VNI 102, and then on the other entry we're tagging, it says VLAN tag 104 to virtual network 1004, so it's going to be virtually this one right here to VNI 104. Okay, so let me go ahead and clean up some of these highlighting marks. So let's go ahead and get rid of this, and let's get rid of these lines, and let's check what is called the spine 1. Let's look at the configuration on spine 1, but before I do that, let me get rid of this. Okay, so now let's go ahead and do spine 1. Let's do show running configuration compressed, and let's see what we find here. Okay, on this spine 1 there is only one BRF, which is gonna be the BRF default. So let's go ahead and draw a switch here. Let's draw a switch for spine 1, and let's draw a switch for spine 2. And what it's saying here that we only have one BRF, which is going to be this BRF default, and then it's recommended to create another BRF for the management interface, which is the out-of-band management 111. Okay, so that will take care of that. So let's continue going down this leaf 1. Let's go ahead and pass all the port groups. Okay, so now I see that there is an interface VLAN 1. So on this particular switch there is actually a VLAN 1 for on-tag traffic. Then we have interface loopback 0 that I mentioned many times, right? That has the IP address of 10.1.1.3/32. So let's write it down here. Loopback address 10.1.1. Let's see here, 3/32. Then the management interface is gonna get an IP address automatically by the DHCP server. Then the rest of the ports are going to be part of access VLAN 1. Now let's take a look at interface 112 on spine 1. So let's use a highlighter here, and let's look for link to leaf 1, which is going to be 112, which is this one right here, and the IP address for that port is 172.16.3.1.30 checked. So that's going to be the port going down there. And then the MTU 1650, but you can change it to jumbo frames like I mentioned before. Just make sure all the MTUs are the same on all these multifunction switches. Then let's take a look at interface Ethernet 113, which is going to be the link to leaf 1. Yeah, something is going on here. So 112 is going to leaf 1, and that port is 172.16.3.1, which is that one. And then the other port, which is going to be this one right here, Ethernet 113. Okay. So basically, that description is wrong. I should have written down. I should have write down description link to leaf 2. Okay, so that is a cosmetic thing. I need to change this to leaf 2. But let's verify the port on 113, right? So it's 172.16.6.1. So the port is good. I just have to change the description. Instead of saying link to leaf 1, change it to link to leaf 2. I'll just make a note. Okay, so that's fine. So that's gonna allow us to, you know, communicate with this other leaf. All right, so let's continue. So another thing that we're doing on spine 1 is that we are turning on the router BGP, and we're gonna give it an ISN number of 65022, which is gonna be the same ASN number for both spines. We're gonna go ahead and relax the rules, allow to have ASN 65022 play with ASN 65021 on this fabric. Then specify to allow the address family IPv4 unicast. We're gonna redistribute all the connected routes to that spine 1. We don't have any on this topology. And then the neighbor, one of the neighbors is 172.16.6.2, which is gonna be this one right here, which is leaf 2. And the remote autonomous system is 65021, which is correct. And then the same thing we're gonna do here, address family IPv4 unicast, no sender side loop detection, just to avoid any corruption. So that's important to have this entry. Then let's go ahead and do neighbor 172.16.3.2, which is going to be this one over here, leaf 1, and then it's part of 65021 autonomous system. We're going to allow this IPv4 unicast address family. The same, make sure that we have no sender side loop detection. And then for the overlay, we're going to be using the what is it called, the IP address for the VTAPs that are part of the loopback 0 on the neighbors, right? On each of the multifunction switches, you have loopback 0 as the identifier for this process. So neighbor 10.1.1.1, which is going to be leaf 1, that makes sense, which is part of the remote autonomous system 65021. Send community extended to allow the injection of routes and all the other commands that I have mentioned on the previous ones. Let's see what else is important here. Yeah, we're enabling the address family L2VPN, EVPN, for that EVPN process to update the databases on each of the multifunction switches, so that way the VTAPs know what type of host sit behind each of them. No sender side loop detection. Then it's showing neighbor 10.1.1.2, which is leaf 2, remote address 65021. So this is leaf 2. So let me keep on scrolling down, and then we reach the end. So that's pretty much how the running configuration looks for the leaves, how the running configuration looks for the spines. Now the next step is to do the verification, just to make sure that these VTAPs for the overlay are actually sending information from VLAN 102 over the VNI 102, which is on the overlay, then coming down on VTAP number 2, and then being able to go into the underlay and reach the destination 192.168.102.11. And not only that, but also being able to go from VLAN 102 and reach 192.168.104.11 VLAN 104, which is in a different segment, right? virtual segment, and then it's gonna demonstrate how these BTAPs can serve as the L3 gateway for each for the overlay. And okay, so I'm gonna stop here and do the verification. Okay, so let's go ahead and do some verification on this lab. So let's go to leaf 1, and what I'm gonna do here, I'm gonna run this show virtual network command, and let's see what it says here. So by showing the virtual network command, it's gonna identify the virtual network 1002 and the virtual network 1004. These are the overlay networks, right, that were created. Let's see what else it says on 1002. It says that the member of this virtual network 1002 is VLAN 102. Remember that we tag it. We tagged VLAN 102 to the virtual network 1002, which is perfect. Ethernet 111, which is the port going to the host, the end host 1. Then the VxLAN virtual identifier is repetitive, but it's right here. The source interface is going to be loopback 0 for this particular virtual network, which is 10.1.1.1, which is a part of leaf 1, so that's in line. The remote BTAP, and remember that the leaves are the only ones that have the BTAPs, right? So the IP address for the remote BTAP is 10.1.1.2, so that's in line. So the remote BTAP is 10.1.1.2, which is going to be leaf 2. Then for the virtual network 1004, VLAN 104 is tagged to it. It's a member going out from Ethernet 114 to endhost 2. That makes sense. VxLAN virtual network identifier 1004. The source IP interface loopback 0 is the same as this leaf 1, 10.1.1.1. Then the remote BTAP is going to be 10.1.1.2, which is going to be the other BTAP 2 on leaf 2. And so let's go ahead and continue. Well, let's do the same on leaf 2, and then I'm just going to glance over. Okay, 1 second. Let's go ahead and run the same command, show virtual network. So let me go here and show virtual network. Okay, yeah, okay, so checked. It's basically what I just read. On the other one, the only difference I see here is that the remote BTAP in this case, because we're in leaf 2, is going to point to the other remote BTAP, which is leaf 1 with the source IP address 10.1.1.1, which is the loopback address for leaf 1. Alright, so let's continue to the next command. It says here on leaf 1 and leaf 2 do the VxLAN VNI validation. So let's go back to leaf 1 and drag this command, show EVPN EVI, and then it's showing that the state is up. The bridge domain is going to be virtual network 1002. Remember that we have two types of bridge domain, a regular VLAN, right, layer 2 VLAN, and another type of bridge domain is going to be a virtual network, in this case 1002. So that makes sense. VNI1. and this is interesting, route distinguisher. I've never seen this before. So this route distinguisher, by looking at this number, is showing us the loopback address for this leaf, which is 10.1.1.1. Then it's specifying that the VNI number, which is 1002, and by some reason is adding this one here. So that's interesting. Yeah, I'll check just to make sure what this means over here. I don't know if it has to do with multicast. I'm not sure. I need to find out. And then it says route targets, and then it has one thing that I can see here is that the autonomous system 65021, which is this leaf belongs to that. And inclusive multicast is going to be 10.1.1.2, which is the loopback address of leaf 2. And then the IRB in this case is going to be 10 and 1, which is the VRF that was created for this EVPN BGP creation. And for 1004 it's going to be pretty much what I just said. I just don't want to go over with the difference that in this case, well, no, well, actually it's the same. I'm looking at the only difference is that this is version network 1004, and it's showing the same thing but referencing to 1004. All right, I think I'm getting too wrapped up around the axle on this one, but yeah, it's the same. It's actually showing you that they're both up. Let's see what is the next command. EVPN BGP summary on leaf nodes. So let's go to leaf 1 and run that command. Show IP BGP L2 VPN EVPN summary. Let me see if I can understand this. Show IP BGP L2 VPN EVPN summary, and it's showing that the neighbors for leaf 1, remember for the overlay, this is the BTAP address, is going to be 10.1.1.3 and neighbor 10.1.1.4, which makes sense. This one is for spine 1 and this is the loopback address for spine 2, and they are part of autonomous system 65022. So that checks, and it's going to be the same for leaf 2, so I'm not going to run it. So let's go ahead and do show IP route. And now let's see what it says here. Some of the codes here are C for connected routes, S for the static, B as Bravo for VGP, internal VGP, EX external VGP, EV EVPN BGP. So this is the one that we are using for the overlay. Okay, it's a VGP, but it's a learn on the overlay. And let's see what else. O is for OSPF, N for OSPF NSSA, E2 for OSPF external. So let's go down to this table. We only have connected routes and BGP routes. So some of the connected routes are 10.1.1/32 on this leaf 1, which belongs to the loopback address, and that makes sense, it's connected. Then we have the external route that was learned through the BGP process, which is 10.1.1.2, which is for leaf 2 loopback. Then we have another one route that was learned by the BGP process, which is for 10.1.1.3/32, which is for the spine 1. Then we have here the other route learn, which is 10.1.1.4/32, which is for spine 2. Then we have a connected route for some of the ports, right, which is 172.16.3.0 and 172.16.7.0, for example. And then there is a couple more routes that were learned through the VGP process, and here is the gateway information, and this is where, you know, via, let's see, there is some metrics, and it's gonna be the same for leaf number 2. Let's see what else. Now you have confirmed the network is operational, and on the switches the final test is to check the end host connectivity is in place using VxLAN. To do this, you will run a simple ping test between end host 1 and end host 4, because they are not only on different VLANs, they are on different VNIs, and this is going to demonstrate that the routing is going to happen not only on the other underlay but also on the overlay. By doing this, you will check the routing across VNIs 102 and 104. That is lovely. So let's continue. Okay, so it says to go ahead and go into end host 1. So let's go to end host 1, which is this one right here. Let's go ahead and log in. Admin, just keep in mind this is a DELL OS 10 virtual switch that is mimicking a server. So let's continue. Then it says to go ahead and ping. Let's make this bigger. To go ahead and ping 192.168.104.11, and I think it's a 10 times 10 replies or something like that. So let's go ahead and check. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's, yeah, the 10 replies. Okay, so that's good. So this will conclude the lab. It's showing that, yeah, we can ping from host 1, VLAN 102, all the way to end host 4, that is in VLAN 104, and this EVPN BGP fabric is created and working successfully. So I'm seriously thinking whether I need to do lab 7. Lab 7 basically is gonna be kind of the same thing. The only difference is that it's using BGP unnumbered for one, and another thing that is using is being able to do external routes, type 5 external routes going to another domain, and but then I need to also start doing the labs for Sonic, the Sonic operating system, which is an operating system that is being used by a lot of hyperscaler companies, big companies, and that operating system was built from the ground up to be flexible and to be used on the cloud, and it has a lot of automation tools that will make the deployment for large networks easy. Well, easy because when dealing with tens of hundreds of switches, and that is the whole idea, to have an operating system that was built from the ground up to work not only on premise but also on cloud networks, and that is a very interesting proposition. So I need to think about it. What the heck, I think I'm gonna do lab 7 as well. All depends on how many people is interested in doing that, and for me to show that. And that's it for this one, lab number 6, and right here.